So in summary, these are the two equations that we derived together. Okay? And we can write them as a system of two equations, two unknowns. We can transform it also in matrix form if you want. Okay, so here we have for the first equation the coefficient of a0 is n, the coefficient of a1 is summation of xi, which is sx, while b coefficient is summation of yi, which we can call to reduce يعني, to have a simpler notation sy. Now for the second equation, we have the coefficient of a0 is sx. The coefficient of a1 is summation of xi squared, so we call it as xx. And for b, we have sum of xiyi, we call it as xy. And here, it's a system of two equations with two unknowns. We have several possibilities to solve it. We can use Kramer rule, we can use Gauss elimination, we can use LU factorization, you can use inverse matrix, you can use Jacobi method, you can use Gauss-Seidel, and all of these techniques that we have learned before, you can use them. Here, they did the conventional technique لأنه it's a simple system. So you get a0 and a1, function of sxx, sy, sxy, sx squared, and then and n. Okay, and then
دكتور
from now
هنا على
on.
الكالكوليتر
نعم.
هنا أعملهم إنه هون على
Hey,
الكالكوليتر
honey,
أو
you
لا؟
can. Yes, here you can. أصلا
Yes.
here you can directly use إذا عندي linear fit Karen, you can directly use هول the final result. But why I am developing the method for you لأنه بعدين إذا بيجيكم matrix يعني مش in case of non-linear fit حتكون الماتريكس أكبر يعني مش 2 by 2 فيها تكون بالكوادراتيك بتصير 3 by 3 بالx cube بتصير 4 by 4 etc. So you should be familiar with these notations لأنه حنرجع نستعملهم after. Okay. So now let us consider an example to understand better how to apply these formulas. So as I told you, in general, they give you a table of data, and they tell you, for example, here, use the least squares linear regression to find the fit for the given data. So here first, I determine the number of points, 1, 2, 3, 4, 5. So n is equal to 5. Then I add a column, which is the summation. My first row, I do summation of xi. So summation of xi will be 0 plus 1, 1, plus 2, 3, plus 3, 6, plus 4, 10. So I get sum of xi. Then I do now summation of yi. So I do 2.81 plus 4.37 plus 6.49 plus 11.995 plus 14.1. I get the result here. And I still need to find a0 and a1. I still need to compute two other summations, which are sum of xy, xyi plus summation of xi squared. This is why I should add to my table two other rows. Okay, one will be x times y. So all I have to do is to multiply. So here 0 times 2.81 is 0. 1 times 437 is 4.37, etc. I will do the same for all points. And then I will add here, I don't forget at the end to add sum of x times y. And finally, the last row will be x squared. So here I have 0, 1, 4, 9, 16. And if I add them, I have 30. Okay, I get 30. So now once all of these are computed, all I have to do is to do replacement in these equations for a0 and a1. So doing so here you have all details of calculation for all summations. You have the results. We can verify already these two, we obtain the same result. You can verify for these. And now we do the replacement substitution and we get a0 and a1. And now to see if this fit is good, we can do a graphical representation. So if I represent my points and I represent the linear fit I did using the minimum, the least square regression, I will get the following graph. It seems that this fit is good because I have 3 points nearly on the line, and here I have small deviation for these two. So I can expect here that this is a good fit, but this is a qualitative analysis. If I want to give a number, do a quantitative analysis to know if the fit is good or not, I develop a formula that will tell me if the fit is good or bad. So we can always find a fit. So whatever is your data, if you have several points, you apply these formulas, you come up with a linear fit. But this linear fit can work in a very good way, like as we have seen in this example, but it can also be very bad. How to know this by calculation? We can quantify the goodness of the fit by using the coefficient of determination, which is called, or also we can say it's the correlation coefficient R. The correlation coefficient R, so when we do it as R square, we call it coefficient of determination. It's equal to ST minus SR over ST. And R, which is the correlation coefficient, is the radical of ST minus SR over ST. Now, the correlation coefficient R can be between 0 and 1. And when it is equal to 1, this means that the fit is perfect. Why? Because if R is equal to 1, this means what? This means that SR is 0. Because to obtain R square equal 1, I should have here ST over ST. So SR will be 0. This means that the error is minimum. I have all points on the line, which is perfect. This is the case if already it's a perfect linear equation, and then I'm trying to do fitting, then all points belong to the line. This is the case where I will, of course, if it's an experimental data in general, it will not be the case. We will always have deviation. But in case I have another application and I just give points, okay, it can be. So if R equal to 1, then it's a perfect fit because SR will be 0 and all points will be on the line. On the other hand, the worst case scenario is to have R equals to 0. Why? Because if R equals to 0, this means that ST is equal to SR. And why this is a bad scenario? Because what we did here, when we defined, if you remember, the standard deviation, we said that the standard deviation will compare the position of data points compared to the mean. Okay? Now, in case we obtain ST equal SR, then we were not able to obtain, if you want, a curve with a slope. The slope was 0. We were back to the case of just comparing with an average value, which is, this means that the linear fit failed. Then in the equation y equal a0 plus a1x, you obtained a1 equal to 0. So you're not able to find a certain coefficient that will minimize more the error between the straight line with a certain slope and the data. So you just end up with going back to the standard deviation, which just measures the deviation from a mean. Okay? So this is, and R in between, for any case in between, R will be between 0 and 1. Okay?
Doctor, what is SR?
SR هي الايرور، هي السميشن اوف ايرور. كارين اللي عملنا لها ديفينيشن هلا، احنا مش كان بدنا نعمل مينيمم للايرور. SR هي summation of error square. Okay? Look, I will go back to the slide of definition so you can see it in comparison with the standard deviation. هون قلنا انه comparing SR with standard deviation. Standard deviation compare the deviation of yi from the mean value، بينما ال SR compare deviation of yi from the fit line. إذا بيطلعوا SR equal ST، ما قدرنا لقينا إنه A1 0 هو best choice. رجعنا عم نعمل comparison with respect to a mean value. ما قدرنا نلاقي line with a certain slope different than 0 تقدر تعطينا a better fit. Okay?
دكتور، هلا الواي بار هي الافريج اوف اول ذا بوينتس، والثانيه هي اللينيرزيشن، وقت رسمنا اللاين
هيدي الفيت. يس، هيدي الفاليو اوف ذا فيت على الاكس اي. اوكي؟ انت اذا بتتذكري هون بالستاندرد ديفيشن we were comparing all values لل just one value اللي هي المين، اللي هي in red هون. بينما بالlinear fit instead of comparing with just one value بنعمل linear fit بطريقة إنه كل value will be compared with a corresponding point على straight line. إذا أنت طلع لك بالآخر بعد الأناليسيس إنه لقيت إنه المين هي أحسن value تتخفف الإيرور، يعني ما عندك slope، يعني ما نجح linear fit. Linear fit was not successful in this case. لأنه رجعت بالآخر إنه minimum error can be obtained if I consider a mean value. And this will be the case لما تكون البروفايل very different from a linear profile. Okay?
Yes.
Any other question on this?
دكتور يعني إذا منا لينير يعني الافريج الاس ار ما رح تكون قريبة للاس تي.
ايه اذا ناجحه اللينير، ما هيدي اللي عم نقوله حسن. انت بس تعمل لينير فيت السلوب في يكون فارينج من 0 لانفينيتي، صح؟ يعني الفيت تبعك كان بي اوف لارج فاريشن. هلا اذا طلع معك الفيت، يعني طلع الفيت that will minimize the error correspond to a slope of 0، يعني رجعت انت للستاندرد ديفيشن، يعني ما قدرت لقيت an equation with a slope different than 0 تقدر تخفف لك الايرور اكثر. So this is the worst case scenario، انه اللينير فيت يعطيك just المين value. اوكي؟ بنكون ما استفدنا بشيء، يعني ما قدرنا لقينا line مع a certain slope تقدر تخفف لي هالايرور. So this means that the linear representation was not convenient in this case. بينما إذا طلع لك ال R equal to 1، يعني إذا طلع لك الريشيو هون. So if we go back to the slide، لما R تكون equal 1 يعني SR okay was 0 and this means إنه the error was minimized to the maximum. Okay, this is why we said إنه لما R 0 يعني SR is 0 so minimum error to the maximum يعني perfect match، يعني all points are on the straight line. بينما لما تطلع ال R equal to 0 يعني ال SR okay is equal to ST، يعني ما قدرت تلاقي slope equation with a certain slope تخفف لي الerror، رجعت كأنه SR is the same as doing standard deviation العادية. So this means that my linear fit was not successful.
Yes.
Okay.
Doctor, can you go back to the slide where we had the mean horizontal?
Yeah. This one.
Okay. Yes. هون الاس ار او اللي تحته مهم، هون الاس ار والاس تي مش كثير قراب على بعضهم.
بلا، لانه هون مثلا بيطلعوا قراب على بعض exactly، لانه الداتا ما عندي اذا بجرب يعني لما يكونوا كلهم اذا بدكم ب certain interval يعني منا linear، منا كثير linear، يعني ببين من هيدا البيهيفير. حتى هون يمكن يكون ببيهيفير كانه oscillation، صح؟ يعني it's highly non-linear. بمجرد ما تشوفوا الفيجر ببين معكم انه اللينير فيت ما حيكون ناجح كثير. يعني انا هلا اذا بجرب اعمل لينير فيت حيطلع لي الار relatively small، اوكي، حيطلع لي close to 0، يعني حارجع كانه الاس ار قريبه كثير على الستاندرد ديفيشن.
اوكي
yes exactly. So now what about if I have a non-linear trend? When I can do linearization, okay? So you have many functions that can be linearized in a very simple way. Because why we do linearization? Because as you can see, finding the linear fit is very simple. يعني linear fit هو أهين من any other possible fit، لأنه كل ما زدنا الديجري للفit كل ما صار عنا number of unknowns بيزيد. يعني مثل ما شفنا إذا if you are doing a linear regression you have two unknowns A0 and A1. If you want to do a quadratic fit بصير عندنا 3 unknowns A0 A1 و A2، وكل ما كانت الفيت degree تبعه اعلى كل ما النمبر اوف unknowns حيزيد. يعني in general number of unknowns هو إذا بدكم الديجري plus 1. يعني لما تكون linear بيكون عندي x to the power 1 وبدي اخذ coefficient ل x to the power 0 اللي هي 1. so بصير بدي a1 و a0. يعني عندي هون على طول عندي the number of unknowns n of unknowns is equal to the degree plus 1. اوكي لما يكون عندي linear يعني degree 1 فبيطلع لي number of unknowns 2. لما يصير بدي اعمل quadratic fit بصير عندي second degree equation. اوكي so in case I have a quadratic fit بصير عندي x coefficient ل x square coefficient ل x1 coefficient ل x0. ساعتها if I apply the general rule النمبر اوف unknowns حيكون الديجري اللي هو 2 plus 1 3 etc. كل ما زيد الديجري حتزيد number of unknowns. This is why if I could linearize my data this will reduce the computational time for me. What are the type of functions that can be linearized? First, I have the exponential variation. Okay. أكيد إذا increasing أو decreasing both will work. So if I have an exponentially increasing data ومن بس تشوفوا الداتا دغري you know يعني من ال behavior تبعها you can say إنه it seems that it follows exponential profile. So I can define it as y equals to a certain coefficient alpha 1 times exponential of a coefficient beta 1 times x. If I define it in this way, okay, and how can I transform this equation to give me a linear equation? نحن بنعرف إنه when we do ln of exponential بيطلعنا الفانكشن هون اللي هي exponential times a function بس نعملها ln بتصير تعطينا الفانكشن. So from here the idea of doing ln for both sides. If I do ln for both sides, what do I get? I have ln y equals to ln alpha 1 times exponential beta 1. Now we know that ln of a times b can be decomposed into ln a وهذا اللي حيعطينا linear relation ln a plus ln b. If I do so I get that ln y is equal to ln alpha 1 plus ln exponential beta 1x, and ln exponential beta 1x is nothing than beta 1x. So now I can say if I do a change of variables, if I set big Y equal to ln Y and I set big X equal to small x, then I will get the following relation. Big Y is equal to A0, where A0 will represent ln alpha 1, where alpha 1 is a constant, and plus A1 times X, where A1 will represent the constant beta 1. So all I have to do then, since the ln, when I do ln of both sides, I will get a linear relation between ln y and ln x. I can transform my data. So if I know that my data has an exponential increased behavior, I can say, I can compute ln y and ln x, and I do a linear fit to relate ln y and ln x. Then once I find the coefficients A0, A1, for any value of small x to small y, I can find the corresponding value of big X, big Y. Okay, and this will help me into doing a fit equation in a very simple way. Okay, because the linear fit is the easiest possible fit I can do. In other examples on linearization, another type that we encounter a lot in engineering applications is the power law fit. So if you have points that follow an equation of the form alpha 2 times x to the power beta 2, then also here you can linearize the data by just applying log for both sides. So if I do log of y equals to log of alpha 2 times x to the power beta 2. Also here, log of a times b is equal to log of a plus log of b. So I get log alpha 2 plus log x to the power beta 2. And then
log هون هي ln.
لا ما ضروري تكون ln، فيها تكون log، يعني انت هون log of a to the power b هتكون b times log a. يعني فيك تستعملي هونيك وقت يكون exponential اجبري تستعملي ln، لانه ln exponential هي اللي حتعطيك ال point desired. بس لما يكون عندي حيلا number to the power اوكي فيك تستعملي log ساعات. اوكي so log x power beta 2 هي beta 2 log of x, and then you have that you can define now that big Y is log of Y, okay, and you have that big X is log of X, and then you can say that the relation between big Y and big X is linear. So big Y is equal to A0 plus A1 times big X, okay? And now if I put it on a log-log scale, if I do the graph on a log-log scale, I will obtain a linear graph. And therefore, in this way, I can perform linear fitting, and then I can find any required point in the power law fit. Okay? Yani what will be the method? If they give me small x, small y, I do the transformation to big X, big Y. Okay? And once I find the fit here, then for any value, let's say if they tell me for a certain value of X, what will be Y? All I have to do is to compute log of X, small x, replace it in big X here, and then get what is big Y. And knowing that big Y is log small y, I can calculate small y. So in this way, I can use the linear fit to get for any value small x the corresponding value small y. Okay?
دكتور
Yes.
بس وقت يصير معنا البيج واي كيف بنرجع بنجيب الواي الصغيرة؟
على الكالكوليتر. يعني أنا
في
إذا
inverse
بعطيك big
لله؟
Y، أوكي. Once I give you يعني إذا عم نحكي هون let's say you know the value of log y, okay, equals to big Y. So then you can say that تعمل الباور يعني let's say هون are using log power 10, okay, you say that 10 to the power big Y is equal to small y.
اوكي لانه هيدا ناسيين شوي.
Okay. Another example, another function that you can linearize is the saturation growth. So if you have a function that is growing and then at a certain stage it will become saturated, so after a certain x it will become a flat plate. This behavior is given by the following function: y is equal to alpha 3 times x over beta 3 plus x. And how we can linearize this data? All we have to do is to do the inverse of both sides. So if I do 1 over y is equal to 1 over alpha 3 times beta 3 plus x over x. Then if I do the expansion here, I can write that this is equal to beta 3 over alpha 3 times x and plus 1 over alpha 3, because I have here x over x, it will simplify, so 1 over alpha 3. So now if I look at this expression, I can say that if I define big Y as 1 over y, okay, so this is big Y, and I define 1 over x as big X, then I will obtain a linear equation of the form big Y equals to beta 3 over alpha 3 times big X plus 1 over alpha 3. So I can say then my coefficient A1, once I get it, it will be equal to beta 3 over alpha 3. And my coefficient A0 is equivalent to 1 over alpha 3. Okay, so now I can, if I have such function, I can linearize it, find the coefficients A0 and A1. And once I find A0 and A1, I can then calculate the values of alpha 3 and beta 3, and then find the saturation growth equation. Okay. Any question on this? And as you can see here, why this equation represents the saturation growth? Because look, as x increases, بيصير beta 3 small compared to x. And at a certain stage, if we still increase x, بيصير هيدا ratio equal to 1. So y will tend to alpha 3. And يعني الفlat plate هيكون equal to alpha 3. Okay? Let us do an example on this. So using the least squares linear regression with a power law fit, هن عادة بيساعدونا بيقولوا لنا which type to use, okay? But we can expect this if we do a graphical representation. And here they told us to do the fit with y equal to alpha 2x power beta 2, okay? So if we want to find alpha 2 and beta 2, we should first find A0, A1, and we use then the relations between A0 and A1, because here, as you can see, after you do the linearization and you get the linear fit, you have a relations between A0 and alpha 3 and A1 and beta 3 alpha 3. So once you know A0, you can deduce the value of alpha 3. And then once you have alpha 3, you replace it here, you get beta 3. يعني حتى no need each time to do the transformation. يعني مش مضطرين انتم كل ما اعطوكم x تعملوا 1 over x وتلاقوا big y ترجعوا تحولوها ل 1 over y. No. ما انتم من بعد ما تلاقوا ال coefficients A0, A1, then from these coefficients you can deduce what are alpha 3 and beta 3. ساعتها once you know them, you can directly, for any x given, you replace x here, you get the corresponding y. Okay? Here also same case, يعني بالlog case same concept. Instead of each time doing transformation, you can just, once you find A0 and A1, you can deduce what are alpha 2 and beta 2. Okay? And then use alpha 2 and beta 2 in this equation. So for any small x they give you, you say that small y is alpha 2 times x to the power beta 2. Okay? Now, واكيد نفس الشيء كمان هون بالفيرست تايب كمان نحن عندنا ال coefficients needed to define function هي alpha 1 و beta 1. So once you find A0, A1, you can deduce alpha 1 and beta. Okay? So you just do this transformation once to be able to find your linear coefficients. ومش مضطرين ترجعوا تعملوا ها transformation each time, because you can deduce the coefficients of your equation function of the coefficients of the linear fit A0 and A. So let us practice here with the given example. First, as I told you, you can do a small graph. The small graph will allow you to suggest what can be the type of fitting that is good. So here from the behavior, it's clear that the power law function can behave in a good way. So, but here they helped you already. They told you to use the power law fit. So for the power law fit, the equation is of the form y equals to alpha 2 times x to the power beta 2. All I have to do first is to transform my data from xy. I will define big X, big Y. And as we have seen together, when it is a power law fit, I will define big Y as log of Y and big X as log of X. And I will perform then this transformation to get what is big X, what is big Y. Now, since I linearized my equation, I expect that the linear fit will work well between big Y and big X. So now all I have to do is to apply the formulas we developed together for the linear fit. And I should add to these rows, I can add here a summation column. I compute first summation of big Xi. I compute then summation of big Yi. Then I add to my table 2 rows, one for big X times big Y. So I do the product for each 2 elements. So here it's 0, here it's 0.301 times 0.9731, etc. I will repeat it for all points. And once I do it, I do the summation for 1, 2, 3, 4, and 5. So here n is equal to 5 in this case. And now I get the summation of xi, yi. The last step will be I still need sum of x squared. So I should also add a row of x squared. So I will have 0, 0.301 squared, 0.4771 squared, etc. Then once I am done, I do the summation of xi squared. Now, once I have all my elements, all I have to do is to replace into the equations of A0 and A1, which will allow me to get the coefficients of linear fit. And once I obtain them, as I told you, I use the formulas relating alpha 2 and A0. Okay, so we have seen that A0 is equal to log of alpha 2. So now to get alpha 2, all we have to say is to do 10 to the power A0 is equal to log of, if I do 10 to the power log, and you know when I do 10 log alpha 2, 10 ولog they are complementary functions. So مثل اللين will exponential. So it will give me alpha 2. Okay. So in this way, I got the first coefficient here, alpha 2 of my power law fit. Now I can deduce the second coefficient, beta 2, from A1, because when I developed the method, A1 was equal to beta 2. So the value of A1 will give me beta 2. And now I completely defined my power law fit, because for my power law fit, I have two coefficients, alpha 2 and beta 2. And then I can verify this by doing a graphical representation. So this is here the log representation. As you can see, log y, function of log x, is a linear curve, while y, function of x, is a power law curve. And just instead of having complexity and computation to find what is the fitting law here, I just did a linearization of my system. So I found the coefficient for the linear fit, and then I deduced what are the coefficients for the power law fit. This is the end of chapter 14. Any question on this chapter?
دكتور
Yes.
هلا هن ممكن ما يقولوا لنا انه مثلا لو باور فيت بصير نحن ويدرو ونشوف اي وحده نستخدمها.
هلا عادة يعني إذا شيء أنا بعطيكم الجراف لأنه ما في وقت كتير بالإكزام. I might give you
Yes.
the graph and you should know from the behavior. ليكو هن كتير هينين يعني. Look, you will know them directly لأنه كتير في فرق بيناتهم. يعني أكيد ما حأعطيكم function not covered in class. بس مثلا هول ال saturation growth بيكون هيك وبالآخر flat. هيدي لأنه بيكون فيها saturation يعني آخر شيء بتصير هلا فيها تكون increasing فيها تكون decreasing. You can have this for example.
Yes.
So once you see this profile of saturation, هيدي بتكون الفانكشن بتكون given by the following formula. When you have الباور لو فيت بتكبر بسرعة من الأول، مش مثل يعني بتكبر إذا بدكم وكمان بتضل تزيد، غير يعني شوي غير عن الاكسبوننشال. هلا هن قراب شوي اوكي، بس يعني هون الفرق انه if you compare them on the same graph so where is the graph؟ عندنا مثلا بالاكسبوننشال no I'm not finding the slide يلا just one minute. نحن بلشنا اول فيت بالاكسبوننشال انكريز. اوكي هلا الاكسبوننشال انكريز والباور لو فيت شوي بيشبهوا بعض، بس بتلاحظوا انه الباور لو فيت بيطلع اسرع شوي بالاول. عرفتوا كيف؟ يعني this is how I can do a little bit differentiation. انه الباور لو فيت بيطلع من الاول سريع، بالاكسبوننشال في عندي بارت صغيره، يعني اول ما تكون شوي ابطا وبتصير تزيد. اوكي، بينما الباور لو if I represent it on the same graph تكون شوي من الاول اسرع، يعني that's it. هلا الباور لو اكسبوننشال يمكن بيضيعوا شوي بيناتهم، بس as I told you يعني بالاكسبوننشال بتكون شوي ابطا بالاول وكثير بتسرع بعدين، بينما الباور لو بتبلش سريعه شوي من الاول. يعني if I want to draw on the same graph الاكسبوننشال بتكون شوي فلات اول شيء، بترجع تزيد بعدين. اوكي
Yes دكتور.
هلا how you can know which one is better for example إذا function مش كتير واضحة. Let's say you want to compare the power law fit مع exponential fit. You do linearization for both and you find R for both cases. يلي ال R تبعه أقرب ل 1 هو بيكون الأحسن. Okay. Any other question on this?
Doctor, can I consider how to differentiate between the power law and the exponential؟ إنه exponential ما بتبلش من زيرو.
ما أنت فيكون عندك plus شيء إنه إيه هلا هي إذا of this form صح، يعني إذا أنت you are considering just the form without plus a constant, yes you can say this. أوكي يعني أنت هون عنا إنه هون ما حتبلش من زيرو إذا ما في plus constant برجع بعيد. فنحن إذا ما عم ناخذ ال cases plus constant عم ناخذ ال case just as like this, yes this is another way to find the difference. إنه ال exponential ما حتبلش من زيرو. أوكي بينما ال power law fit حتبلش من زيرو. هيدي second difference. بس أنا عم بحكي in general إذا عندك plus constant هون فيهم اثنيناتهم ما يكونوا مبلشين بزيرو. كيف؟
Yes, doctor. Thank you.
Any other
دكتور
question? نعم.
بس I have a small question concerning the test بس لنلاقي مثلا inverse كيف بدنا نحط لك اياها على بلاك بورد؟ يعني بحط row 1 وبحط الاليمنتس
انا كان بدي اعطيكم الريمارك. انا بالاكزام اول شيء بليز بالاكزام كثير اقروا منيح السؤال، لانه انا في كثير قصص كثير طويله ما بدي ضيع لكم وقتكم تعملوا كل البروسيجر. يعني مثلا بالانفرس حاطلب 1 كولم منه، يعني يمكن اطلب الفيرست السكند او ثيرد، حتى بطلب تيكون نمبر واحد ما تضطروا تفوتوا 3 نمبرز. حاطلب السميشن، يعني يمكن لكم give me the summation of elements of the first column of a-1 او of the second column of a-1. اوكي يعني انا ححدد، مش حاطلب كل ال a-1 لانه انا بهمني تكونوا فاهمين البروسيجر، ما حعد لكم نفس الورك عدة مرات. so I will ask for something specific. فبليز كثير اقروا منيح السؤال، اذا واحد ما انتبه بيضيع نص الوقت تيجيبها كل a-1. اوكي I will be very specific. please ركزوا 30 ثانية تشوفوا شو مطلوب، لانه this will save you a lot of time. يعني أنا عادة حأطلب column معينة وحأطلب summation of the elements، فتقدر تحط ببلاك بورد البوكس one number، وبرجع بعيد اللي ما بيوصل لجواب ببلاك بورد بحط الفلاش ستيتمنت. ما بدي empty box، اللي حط empty box أخذ زيرو بالإكزام. please guys. اوكي
دكتور
هيدي يس
دكتور
التايم
في شيء
الميتينج حيخلص. إذا حدا بده شيء
ايه دكتور انا بس
يحكيني على واتساب. اوكي يلا باي باي.